Hello, everyone. My name is Ron. I'm a senior software developer at Nvidia. And I want to talk about a problem that makes AI researchers go crazy every day, at least our customer. And basically, when running, doesn't say anything. So I want to take you like a story that most AI researchers see every day. They have their Kubeflow, PyTorch, LLM training job that they know that runs perfectly fine. They run kubectl apply, and boom, they have their job ready to go. 1 minute pass, and they check the status of the job. And it looks running. Nothing goes wrong. Pods looks healthy. Status is good. And then they decide, yeah, I can go grab a coffee, do anything else, and life is good. But fast forward, it's 11 a.m. They decided maybe it's a good idea to check what is going on with my training. So they get to the logs and they see this. Errors of errors, I have errors of IP network issue. Okay, so what happened? They basically spent 2 hours of GPU doing nothing, accomplish nothing, and maybe got AWS another $1,000 for nothing. You know, GPU is very expensive. But if you look on the job, it still say running, which is not very user-friendly if you ask AI researchers. And what's going on here? Most AI training frameworks checks for pod readiness, meaning when the pods are ready, the job is ready. Sound very simple. But what is pod ready? Most of them that comes from Kubernetes might know, but for a researcher, it's an unknown. So every pod have a journey from creation to readiness. It started from the user submit an API call to create a pod. Then it gets scheduled and placement in a node. Then there is a init container or not that runs until completion. And this is the pending phase. It's a very vague phase. It says a lot, but it's a long, long period. Could do a lot of things in this period of time. And then there is a running phase where the container starts running the main container. And eventually, if it passes all the readiness probe, it's ready. But readiness probes are not meant for AI application. They are meant for microservices, where your readiness probes say, I'm ready to go. But AI applications are not pods only. So if we look at a typical PyTorch training, actually look like from a Kubernetes standpoint, like entities, it's just few pods and a service. Simple and that, yeah. Look very easy, look very stupid. But as you know, it's not just those pods. Every pod has a meaning. So they communicate with each other. And this is really important because Kubernetes see those entities as separate. It checks each pod healthy, but it does not check them as a whole. And this is one of the gaps that AI people doesn't really know or understand from their standpoint. So if we look deeper on what those pods doing together, so we see a few like main patterns. So at the first one is on the top, we can see service discovery. Basically, how pod can reach other pods by DNS resolution. But DNS resolution is just the first step. All those pods are communicate either by ring topology, broadcast pattern, or point-to-point communication. And this is where the problem lives. If DNS fails, if network policy blocked, if any connectivity issue happened, nothing is happening, and it just stuck. But from Kubernetes standpoint, it does not really care. So let me show you the disconnect. When researchers accept running, they accept progress. They mean GPU. They don't mean to look on those logs all day. So when Kubernetes says it's running, meaning all the pods are just past their individual readiness probe. The network is created, but they don't talk about network. It's left unchecked. Also, the health of the AI application itself is taken for granted. It never checked. So now when you know the gap, what I'm suggesting is two things. First one, do as much pre-flight checks as you can. Check for connectivity. Check for GPU communication. Do all those things and more before your AI training begins. And during training is a long progress, meaning it takes time. It could be even days and weeks. So we need to check every day, every time. For real-time errors, don't wait for 2 hours for checking the logs. Also, keep track of actual progress. Are checkpoint written? If your GPU utilization is more than 0, where it should be? Those indicators are real progress for your AI application. And continuous validation. As you know, life and Kubernetes change, and we need to check all those pre-check validation in a liveness process. Not only check the application lives, yet the AI application actually lives, and move forward. And the gap between infrastructure status and the application reality is real. But now you know the difference and how to gap it. Thank you, everyone.